Hi, this is your 5-minute geography lesson. We're covering Theme 3, Element 3, Tectonic Landforms. Underline the date, entitled with a ruler. I'm Mr. S, and I'll be your 5-minute teacher. At plate boundaries, there are 4 basic landforms that you need to know. These are fold mountains, mid-ocean ridges, ocean trenches, and volcanoes. We'll begin with what we find at constructive boundaries. Now, at both the types of boundaries we're going to look at today, you will always find volcanoes. But there are different types of volcanoes, and at a constructive boundary, we find shield volcanoes. Now, a shield volcano is characterized by having a really wide base. So that's the bottom of the volcano is really wide. But it doesn't get very tall, so it stays quite short. So it's wide and short, or squat. And the reason for that is the lava that comes up from a constructive margin or boundary is basic lava or basaltic. That is lava that has a very low silica content, so it's really runny, so it's not very viscous. So non-acidic lava, runny, and that means that when it erupts, the lava runs very, very quickly away from the vent, the opening of the volcano. When this dries, it leaves very thin layers of lava. So over time, after each eruption, the amount of land being gained in height is not very much, but because it's running so far away from the vent, it's spreading it out, making that volcano really, really wide. So the lava is not very thick, so it doesn't gain very much height, but because it's runny, it gains a lot of width. In the sense, there aren't any layers, as we're going to see in the next one, because we don't have alternating types of material to produce it. This type of volcano doesn't really produce any ash. They are less violent eruptions, purely made up of lava, and they erupt really frequently. The other 2 types of landforms we need to consider are rift valleys and mid-ocean ridges. Rift valleys are the gap between the 2 plates. So this is one plate here and this is one plate here. As they move apart, it's not necessarily a very clean gap. So on this diagram, it looks like it's just been cut cleanly down the middle. But in reality, when 2 plates move apart from each other, they're going to split and splinter at different locations. So you can see cracks in alternating locations all the way up here. And as they move away, some of the land in the middle may be left whole, and when the gaps widen at the sides, this middle bit drops down. So it leaves 2 sides that are higher, but the middle has been dropped in the centre. This may fill up with water like this has, or it may stay as a dry valley. A ocean ridge, or mid-ocean ridge, is formed by the same process, and what we find is under the sea, when the magma rises up and it's cooled quickly by the water, that it forms on the edge of the plate on both sides. And then the plate moves because of convection current away, and more is formed. And what ends up happening is it creates a lip on the edge of the plate. And as that moves away, you can see where there was another lip here when this one was over here, and the same on. So it creates these ridges moving all the way back through the plate. And these ridges were the point where this part of the plate was once at the margin or the boundary, and has moved away over time due to convection current. So an underwater mountain range caused by the tectonic plates moving away from one another, that molten rock has risen up and hardened to form a ridge of crust at the top of the plate. For destructive boundaries, again we need to understand the type of volcano, and in this case it's called a stratovolcano. Its characteristics are different. It is much taller. These are your typical things you'd probably draw if I asked you to draw a volcano, something that looks like a mountain. They're really tall, but their base is quite narrow. And you can see on here that it's alternating layers. So the type of lava at a stratovolcano is really viscous. It's thick lava. It's made up of a type of lava that has a lot of silica in it, and that silica makes it really thick, which means that when it does erupt, the amount of lava that comes out, which generally isn't as much as a shield volcano, doesn't travel very far from the vent. So these layers end up being thicker because it's thicker lava, and its base isn't very wide because the lava doesn't travel very far away from the vent. However, this type of volcano does produce a lot of ash. So most of these layers are probably more to do with the ash than they are of the lava, but they alternate in terms of layers of ash and lava. These volcanoes tend to erupt very infrequently, so it could be hundreds, and in some cases even thousands and thousands of years between eruptions. And over time the pressure is building up, and because the lava is so viscous, so thick, it takes increasing amounts of pressure to actually force it to a point where the eruption occurs. So these eruptions, when they do happen, are really, really violent. These are the ones that you hear about most often on the news because they cause disruption, death. If you think back to the Icelandic eruptions of 2010, the ash actually blocked the skies so that international travel couldn't occur in planes for months at a time. So these volcanoes, when they do erupt, are really violent, but they don't erupt very often. The other two landforms we need to have a look at are ocean trenches and fold mountains. So ocean trench sounds a bit like ocean ridge, but it's not. The place we're going to look at here is between plate on this side. So this pink is going to represent our continental part of the plate, and this green is our oceanic plate. The bit where the two meet, this faded line here, this is the ocean trench. So it's not a very neat point where the two meet, and you've got the oceanic plate going under. It's going to drag a little bit of the plate with it, and it's going to bend it. This continental plate's going to bend, and it creates a gap in between the two plates. And these locations are actually some of our deepest points on the planet. The Marianas Trench in the Pacific, you could actually fit more than one Mount Everest inside that ocean trench. That's how deep it is. So they're the gap between the two plates. As the oceanic plate is being submerged under, it creates a little bend in the continental plate, and that's the gap between the two. Fold mountains are formed in the same process. So as the oceanic plate is being pulled or pushed down into the mantle, this plate here, the continental plate, is still moving in this direction. So what happens when this occurs? Well, you're going to start getting this bit of the plate crumpling. So if you imagine getting a piece of paper and putting one hand on one side of the page and one hand on the other side of the page, and you push the paper so that you're trying to make your hands meet, the paper in the middle is going to bend up. And that's what's happening to this continental plate. As the oceanic plate is pushing into it, and as that continental plate is pushing into that plate, it's going to make this land here start to fold and crumple until it points into a mountain shape. And this creates what's called a fold mountain. Over time, as this plate continues to move, you'll notice that it becomes part of a continental plate, this pink plate over here. So when this eventually meets, because they're both continental, one of them isn't going to sink. They're both going to stay where they are. So they're both going to force each other into each other. Any sediments in the middle are going to get forced up, and this plate is going to get forced up crumpling, and this plate is going to get forced up crumpling. So continental plate will not be destroyed, but it will be crumpled and forced upwards in the form of a mountain. So talking of Mount Everest, we found sea fossils that you would only find at the bottom of the ocean. And the reason for that is at one point in time, Mount Everest would have been part of this oceanic plate and this continental plate that was once underneath the ocean, but over millennia, they've been forced together and pushed upwards to become the tallest mountain in the world, 8,848 meters tall. And at that point, we actually find sea fossils that were hundreds of meters below the ocean millennia ago. Well, that's it for today. But continue your revision by completing the now tried task for homework. Class dismissed.